Hi, in this final video in this series, I want to talk about some proof strategies you can use in doing simple proofs with the 9 inference rules we've learned. Hi, this is Logic Self-Taught with Dr. Phi. In this final video, we will talk about some proof strategies you can use in doing your proofs. We will introduce the introduction, elimination strategies, and some rules of thumb you can use. Bear in mind, there is no algorithm for doing proofs, so you have to try various things. We will look at the application of the various strategies I will suggest on a proof. You have it here. You have an argument we will show to be valid. Doing the proof, you can try to prove the argument to be valid yourself and then watch the video further. Let's first take a look at the inference rules we've learned and see how we can classify them so that we can use them in our proofs. If you look at the rules marked here, you'll see that all these rules allow us to infer complex propositions. The rules marked in yellow allow us to use information contained in various complex propositions. Another way of classifying the inference rules concerns the type of complex proposition that the rule allows us either to infer or to use. So the simplification and conjunction rule allow us to decompose the conjunctions and to compose conjunctions. They deal with conjunctions. The constructive dilemma is a rule that also employs a conjunction, but in a rather specific setting. Now, these 4 rules allow us to make inferences with conditionals. And finally, disjunctive syllogism, addition, and also constructive dilemma allow us to deal with disjunctions. Introduction rules basically allow us to compose a proposition of a given type, right? So conjunction allows us to infer a conjunction, to add a conjunction to a proof. Hypothetical syllogism and absorption allow us to add conditionals. Constructive dilemma and addition allow us to add disjunctions to the proof. Modus Tollens allows us to add negations to the proof. So whenever we need one of these complex propositions, it's useful to think of an introduction rule that would allow us to enter such a proposition. The so-called simple elimination or decomposition rules allow us to use information from complex propositions of certain type to derive simpler propositions. And so simplification allows us to infer a conjunct from a conjunction, right? So it allows us to decompose conjunctions. Modus Ponens allows us to infer the consequent of a conditional, provided, of course, that we have the antecedent. Finally, disjunctive syllogism allows us to add a disjunct to the proof, provided that we have the negation of the other disjunct available. There are no algorithms of doing proofs in logic, so you're never guaranteed that you'll reach the conclusion, although for most of the simple proofs, there are some good rules of thumb you can follow. We've talked about 2 basic strategies already. We've talked about the working forward strategy and the working backward strategy. We've used the working backward strategy by far the most because that's the goal-directed strategy. In doing proofs, we aim to derive a certain conclusion. Working forward strategy consists basically in your applying inference rules that you see the opportunities for applying. You should not follow the working forward strategy too often, especially when you're new at doing proofs. You can get lost by doing useless steps. When working backward, it's good to use the following rules of thumb. First, try to apply a simple elimination strategy. So when you know that you need a certain proposition, try to see whether you can apply either simplification or modus ponens or disjunctive syllogism in the proof to obtain the proposition. If you can't apply the elimination strategy, then try the introduction strategy. So try to introduce the formula, provided of course it's a complex formula, by an appropriate rule. So if the proposition you want is a conjunction, try to apply the conjunction rule. If it's a disjunction, try either addition or constructive dilemma. If it's a conditional, try hypothetical syllogism or absorption. If it's a negation, try to apply Modus Tollens. Let's look at our proof example. What I'll do in this proof is go through the planning. I will sort of exaggerate the way in which we'll be applying the elimination and the introduction strategies. If you're just interested in how the proof works, you can move on. We have 4 premises. We are to obtain a simple conclusion E. The first thing we do is to try an elimination strategy. So we basically try to locate E in our premises. It occurs in exactly one place. In premise 3, it's hidden within the consequent. To get E, we would first have to get the disjunction A or E. And then we would need the negation of A to apply disjunctive syllogism to get E. But if you look carefully, you will see that, again, applying the elimination strategy, we could get not A from line 4 by simplification. Note that even though we can find not A also in line 2, it occurs in the antecedent of a conditional, and of course we will not be able to get it from the antecedent. But we can get it by simplification from line 4. At such a point, it's actually useful to carry out the first step. But now we need to think further. We need A or E on its own line. So again, we try an elimination strategy first. We try to locate the place where A or E is present. It's present in line 3 in the consequent of a conditional. We know a rule, an elimination rule, that will allow us to get the consequent of a conditional. That's Modus Ponens, but we need to match the antecedent. So we need to get S and H. Again, we first try an elimination strategy. We try to locate S and H in our premises, but the only place where it occurs is in the conditional in line 3 in the antecedent. But we can't get any proposition from the antecedent, so we need to drop that idea. We need to drop the elimination strategy. Let's try an introduction strategy. This is a conjunction, so the introduction strategy will basically mean that we will need to apply conjunction. We've done this many times already. We will need 2 conjuncts on their own lines, S and H. Let's try to see how we can get them. We apply the elimination strategy. These are sim propositions. This is the only thing we can try to do for now. We locate S in our premises. It's present in 2 places. S is hidden as a conjunct within the antecedent of a conditional, so we know we will not be able to get it. We can drop that idea. The other place where S occurs is it's a disjunct within a disjunction. That's a subcomponent. But we will certainly need to get A or S in order to get S. And by the way, note that we already have not A on line 5, so we will be able to get S by disjunctive syllogism. We try to locate H in our premises. Again, we need to drop the idea of trying to get it from line 3, but we can try to get it from line 2. We would need the conditional if A, then H. Of course, now we try to see how we can get A or S, and if not A, then H. We will need the conjunction from the consequent of the conditional in line 2, which means that we will need to match the antecedent of that conditional and get B or G on its own line. The first thing to ask ourselves is whether we can get B or G by elimination. To do this, we screen our premises to try to find where B or G occurs. The only place it occurs is in the antecedent of a conditional, so we know we can't do an elimination strategy to get B or G. We will need to use an introduction strategy, which means that we will need to apply constructive dilemma or addition. Actually, it's always good to try with addition first, because it's a simpler rule to apply. To apply addition, we would need one of the disjuncts on its own, either B or G. Let's try to get B. Let's try an elimination strategy first. We note all the places where B occurs. In premise 2 and in premise 4, B occurs in antecedent of a conditional, sometimes even more deeply embedded. So the only place to get B from would be from premise 1, where B is a disjunct. To get B from premise 1, we would need the negation of the first disjunct, which we have in line 5. So we can follow an elimination strategy to get B. We can forget about getting G altogether. We are finally ready to go. We first begin by getting our first subconclusion B from line 1 and 5 by disjunctive syllogism. We have our first subgoal. We wanted B because we wanted to get the disjunction B or G, which we now can obtain by addition. We know what we have. We have B. We know what we want to add, G. Now that we have B or G, we can match the antecedent in line 2 and get the consequent. We derive the big conjunction by Modus Ponens, and we can immediately apply simplification to get the further two subconclusions that we wanted, A or S, and if A, then H. Now we wanted them because we wanted to have S and H on their own lines. To get S, we need to apply disjunctive syllogism to line 5 and 9. To get H, we will apply Modus Ponens to line 10 and 5. And now we can apply the conjunction rule to obtain S and H. This allows us to match the antecedent of the conditional in line 3. We can apply Modus Ponens to obtain A or E. And ultimately what we wanted was E. We now have the disjunction, we have the negation of the first disjunct A. We can apply disjunctive syllogism and we are done. Okay, this was a long proof. I did exaggerate the planning here. You can do this much more simply, and certainly if you see the patterns, you'll immediately see how to apply the rules. But whenever you're stuck, try to think of these strategies. Try to think about the elimination strategy first and the introduction strategy later.